right, welcome to part 2 of lesson 6.9. This is application problem number 3. So we're going to do this on the second day. Hopefully you practiced a little bit last night, and if you have questions, I'll be more than happy to address them in class. So let's take a look at example 3. We have Charlie and Jenna Hughes, and they're attempting to haul a large sign to the roof of their antique store. If they are standing on the edge of the roof pulling on ropes attached to the sign, the ropes make a 30-degree angle with each other. If Jean is pulling with a force of 105 and Charlie is pulling with a force of 110, what is the magnitude and net force on the sign? So ultimately what we have going on is we have a roof and we have Jean and we have Charlie and we have some sign that's attached with a rope. Okay. And really they are each pulling, the ropes make a 30-degree angle with each other, so we know the angle between them is 30. And Jean is pulling with a force of 105, and Charlie is pulling with a force of 110. And when I look at this picture, it's like a little bit confusing, but that's generally what's happening. But I can align those forces however I want to. So to keep in the very consistent pattern, which I have you guys doing this in, because it makes it easier for many of the students, I'm going to put one of my forces on the horizontal. So I'm basically just going to take I'm basically taking this force here and this force here, and I'm realigning them with the horizontal. So I don't care whose force goes first. I feel like today I'm going to put Jean with the 105 Newton force, and then I'm going to remind myself right here that this is acting at 0 degrees to the horizontal. If you don't understand this, we can address it a little further when you get back or when you come to class, but for this video, I'm just going to put it on the horizontal at 0 degrees. And then we have Charlie, whose angle is 30 degrees between the two forces, and he is pulling at 110 newtons. So when I put these two forces together, I have force at 105, and then I have a force at 110, and then I have this resultant force. So my resultant force is right here, and that is what I'm looking for, and then I'm looking for this angle right here. So just like the previous problems we did yesterday, we are going to take and we're going to find force 1, which is 105 newtons. I don't know why I put that. It's 105 cosine theta, and in this case, remember, theta is 0 degrees. That's acting on the horizontal, and this is 105 sine of 0 degrees. Then I have my second vector. My second vector is 110 newtons, and it's going to be 110 cosine, and the angle between them is 30 degrees. And then 110 sine of 30 degrees. And now I'm going to put those into the calculator, and again, if you'll store this as x and you will store this as y, it really makes the computation significantly faster. So take a minute and put those into your calculator. If you need to hit pause, please do so. In the end, you should get 200.262 for your horizontal component, and your vertical component is just straight up going to be 55. So I'm going to take those to the next page. So I'm just picking up where we left off. And my magnitude, I'm not going to touch my calculator yet. I'm just going to go ahead and write this all out. So my magnitude is going to be distance, or 200.262 squared, plus 55 squared. And my theta is going to be tangent inverse of my y value over my x value. And now, if you still have the x squared plus y squared stored into your calculator, you can literally go find the x squared plus y squared if you stored your new values, and you can do that. Otherwise, you need to type this in and make sure you use the long decimals. We get that our magnitude, after a little bit of computation, is 207.677 newtons. And if I take theta and tangent inverse in my calculator, tangent inverse of y over x is going to give me 15.357 degrees. So if I think of what's happening, I had my 105 Newton force here. I put my 110 Newton force here. You already have this picture. And we found this angle right here to be 15.357. So my answer in sentence form is something to the effect that Charlie and Jenna are pulling with a force of 207.677 newtons at 15.357 degrees with respect to the 105 Newton force. Now, if you did this example before I started, I'm going to go ahead and parallelogram this out. So I'm going to do this. And if you did this right here, this is the 110 Newton force. If you take the combined angle 30 minus 15.357 and you take that, you should get, I'm grabbing a calculator. If you do that, you get 14.643. So you could say that our force, you could copy the same sentence here, and then you get at 14.643 degrees with respect to the 110 Newton force. And that would be the difference. So either of those are right, and if you add these two angles up here, you actually get the whole 30 degrees. So it doesn't matter which one you find, they are both correct as far as homework and test goes. However, you have to claim with respect to in your answer or you will not get full credit. All right, you should be able to tackle the rest of your homework. If you have any questions, do not hesitate to ask, shoot me a message, or you can ask me in class. Have a great day, and I will see you in class tomorrow. Bye-bye.